I'm Camila Cruz, and I will be kicking it off for Team Goes Postal. Like the video shows, we're trying to fly into the future by using the ME6102 Designing Open Engineering Systems group project to develop an open engineering system of a smart mailbox of the future via the P&B approach. In other words, we will be modifying the P&B design approach in order to create a future mailbox.
Coming down here. Oh. Whoops. He's ready to go. How am I going to get this in here?
Throughout the presentation, we will be talking about the team development, the team's learning goals, understanding the problem and the world of 2030, the different course materials used, the customer and technical requirements, the preliminary and final concepts, and the future work needed in order to complete the project.
This is Thomas, and I will be presenting Team Setup. Team 1 had 15 members, 8 on-campus students in Atlanta, and 7 distance learning students, in locations that included Houston, New York, and Florida. One of the hardest part of the project was to organize everyone so that we could all work together. The first step was to create a preliminary Gantt chart. This allowed us to get the ball rolling and organize the rest of our semester. However, because it was developed as one of the first steps in the design process, it experienced considerable modifications throughout the semester. Next, we figured out which storage service the team would use. For this, we took a closer look at Google Drive, Box, OneDrive, and Dropbox. We looked at various characteristics such as individual size restrictions, free overall storage, and offline capabilities. At the end, it was decided that the team would use Google Drive because it provided the most storage at no charge and allowed people to work on the same documents simultaneously. Furthermore, it was compatible with Windows, Mac, Android, and iOS. Subteams were established via the implementation of a Google Doc, in which each class member was asked to fill out information relevant to his or her likes and dislikes as they pertain to engineering design. Prior to selecting a team, a number of criteria, which are listed below, were considered. Skill needed in order to complete semester project and personality type compatibility, for instance, were taken into account. Finally, the sub-teams were created. These included the CAD team, responsible for solid modeling, members including Javier, Kevin, Colin, and LaShawn. The Constellation team, responsible of the paper itself and putting it together, as well as background research. Members included Frank, Gabriel, Fouad, Zachary, Camille, and Victor. And finally, the P&B team, which ensured that the P&B method was being followed appropriately. Members included Van Thuren, Frank, Thomas, and Jennifer. Anna naturally became our leader. This means that she was in charge of organization, task distribution, deadline enforcer, and any other task asked by the team.
Hey everyone, my name is Gabriel Roman and I will be covering the learning goals and objectives for our project. It has been established that this project addresses numerous of the learning goals set forth by the group members. The primary learning goals that can be achieved through the completion of the design project include the ability to critically evaluate various solutions, identify users' needs, come up with ideas individually and in a group, utilize mass communication, and apply a systematic design method. First is the ability to critically evaluate various solutions to a single problem. When presented with problems throughout the semester, multiple solutions will become apparent. The project provides the means to gain the ability to evaluate a multiple of solutions both accurately and efficiently. Next is the ability to identify users' needs. This is a fundamental engineering skill. It is important to be able to recognize which user needs are consistent with time and which needs are a part of the indefinite growth spectrum of a product introduced by the concept of an open engineering system. Next is the ability to come up with the ideas individually and in a group. In both today's world and the globalized world of tomorrow, the ability to ideate and communicate well in large geographically dispersed groups is fundamental. Next is the ability to utilize mass communication platforms and modern product development tools. This team project requires the development of a unique communication and work distribution platform that is catered especially for the scenario that the team is large and geographically dispersed. Last but not least is the ability to internalize, personalize, and apply a systematic design method. The P&B approach to systematic design will prove fundamental in the completion of this project. From these learning goals, the team was able to identify the following learning objectives associated with the course project. Learn to critique a proposed solution, assess the feasibility of a proposed solution, verify that a design meets the requirements of the users, improve an existing design or proposed solution, recommend design constraints based on user requirements, and compare existing designs to recommend improvements.
Hi, I'm Hannah, and I'm going to provide an overview of the deliverable structure adopted by the team. As the team lead, it was important to ensure that we had a system in place to facilitate the forward progression of the project. The first step in developing this system was to determine a functional method of generating tasks, sharing and distributing those tasks, and following up on them upon their completion. As such, we established the following working structure. First, tasks were generated at Tuesday meetings via group discussion and deliberation. On Tuesday evenings, I was responsible for adding said tasks to our working to-do list, which is shown here. Then, I would send a weekly email providing general updates and task details. Members were given until Thursday to adopt tasks on a volunteer basis. We felt this was the best way to hold members accountable for their work. In the event that a task failed to get adopted, that task was assigned using the subgroup structure Thomas shared with you earlier. The following Tuesday was used to evaluate the quality of work and determine what, if any, changes needed to be made. In the week following the deliverable of a task, each task was integrated directly into the report. In order to ensure that team members were pulling their weight, team rules were drafted. The primary points of these rules indicate that, first of all, each member was expected to complete at least one deliverable on a bi-weekly basis. Second, subpar work is considered incomplete work. Lastly, members were required to apologize to the entire team upon their first strike, and strike 2 allowed for a team to vote to determine the expulsion of the member. While these rules are stringent, they guarantee that members complete quality work in the time frame allotted to them.
I'm Francisco Reynoso, and I'll be talking about how our team approached the development of the smart mailbox of the future. The first step was to conduct a SWOT analysis, which allowed for a surface-level investigation of the market for the mailbox of the future. The main challenge for designing the mailbox of 2030 is that the current system already performs all of the vital functions required by most users. Therefore, new mailbox features need to be introduced to the market. The idea is to reinvigorate the current saturated market and change the perception of mailboxes by providing improved functionality and convenience to customers. The United States Postal Service handles 40% of the world's mail, but with the rise of online services like email and paperless billing, there has been a decrease of 23% in mail volume from 2004 to 2013. Nonetheless, the global market for single-user mailboxes continues to increase due in part to an increase in population and the recovery of the housing market. In order to create the demand and shake up the stagnant mailbox market, our design must tap into the customer's willingness to pay for extra features beyond the functions of a standard mailbox. The design must implement added functionality that may be essential to the world of 2030. These features may include the ability to accept delivery of packages following the current patterns of online shopping and the rapid rise in the number of packages being delivered. The integration with automated pickup and delivery services that both the United States Postal Service and other mail delivery services may pursue in the coming years. And finally, the introduction of a mail sorting mechanism that serves to filter junk mail and ensure the delivery of important documents. These features must be implemented by taking into account the potential competitors of the mailbox of the future, which may include digital mailbox services like Manila that transfer physical mail into an electronic format for a monthly fee.
Hi, my name is Zachary Foster, and I'm going to discuss how our team used this course in the aspects of open engineering systems, mass collaboration, modularity, and mass customization in order to make our product successful. The utilized definition of an open engineering system was modified in order to ensure that it applies to our product. Open engineering systems are systems of products, services, and/or processes that are readily adaptable to changes in environment, resources, technology, customer requirements and wishes, as well as government regulations, which enables producers and designers to remain competitive in a continuously and ever-changing global marketplace through continuous improvements, modifications, and upgrades, all while optimizing the applicable life cycle as well as environmental sustainability of the system. An essential portion of the design of the smart mailbox of the future is that its design be an open engineering system. In order to ensure that our mailbox meets the demands of an open engineering system, through mass collaboration, our group generated the necessary requirements list. In order to implement this requirements list for our product, while at the same time minimizing both cost and time to market, the systematic Paul and Bytes design approach was used to design our open engineering system. Because mailboxes are a product that have existed and evolved since any form of mail have been around, it is fair to say that the concept of an open engineering system is applicable to the design of the smart mailbox of the future. Mailboxes have the potential to be modified and customized to meet a broad base of customers and will not become obsolete in the foreseeable future. Ensuring that the final mailbox design meets the requirements list for an open engineering system will provide the opportunity to continue growth in the future. An open engineering system encompasses multiple designs that are adaptable to change and naturally evolve into a multitude of more customizable products. As such, the design approach for the smart mailbox of the future embraces this concept, and the requirements for the first iteration of this mailbox caters to the requirements list for an open engineering system.
Hey everyone, I'm Colin and I'll be discussing the customer requirements today. Our design essentially impacts two separate customers, the box owner and the deliverers. So before we put the pedal to the metal, we decided to research just what the average Joe wants. A survey helped us understand some of the problems with the basic box and flag. While the price cap stands around $100, we found that many owners are upset about things like poor flag quality, wet mail, and a boring design. We also found that many people want options for smart features, like a junk mail sorter or a reception checker for packages. So with regards to owners, the key things to remember are keeping the mail in good condition, including chances for customizable smart features, and to have an aesthetically pleasing design. Our second customer is the deliverer. Since our mailbox will be a step in delivery, we want to assist deliverers as much as possible. Several carriers for the USPS offer design opinions, and efficiency, of course, is of top priority. The simplest interface is best, and spring-loaded lids or small apertures require two hands or multiple insertions for delivery. Since they're on a time crunch, being able to quickly open, deposit, and close the box in a few motions saves a lot of time. They also want to minimize exiting vehicles to avoid slips, falls, and other injuries. USPS also offered data indicating the 30% growth of the packaging industry over the last 3 years because of online shopping and other services. Addressing this could help our deliverers' time crunch and our market share. So with respect to carriers, we want to focus on two things: keeping a simple interface and reducing the impact on delivery time. That way, we offer a design with a seamless transition for the carrier. In order to keep both of our customers happy, all the ingredients must come together. Things like keeping a simple interface for carriers, having integrated smart features for owners, having options for customization for a host of consumer desires, and addressing the packaging market can all be used to create a final product that satisfies both owners and deliverers.
Hi, my name is Frank Dawson and I will be explaining how we arrived at our technical requirements. The job of the technical requirements is to distill the customer requirements into a specification document the design team can use. In order to perform their function, the requirements need to be clear and complete. This is accomplished by mapping the customer requirements to the technical requirements. While the mapping was one-to-one as much as possible, in some cases there was either a one-to-many or a many-to-one mapping. Another area of significant research was understanding the various governing regulations for the mailbox. U.S. Postal Service, Underwriter Laboratory, and ASTM International specifications were used as references. To accommodate an open engineering system and customer demands and wishes, a modular set of requirements was created. The basic set of requirements primarily used the U.S. Postal Service Standard 7B to describe a functional mailbox. This represents the minimum feature set for the product. Then additional sets of requirements were written for customizability, smart features, locking, and so on. Each feature's requirement set is sufficient to understand how that feature interacts with the system as a whole. Additionally, each feature identifies any dependencies to other features. In summary, this modular set of requirements allows the design team to generate a design that meets the current market needs while being fully expandable. Choosing the requirement set to implement and combining the features to create the completed product does this. The team may also choose an alternative set of features to implement, fully leveraging an open design.
Victor Winery here, speaking on the team's developed function tree. A function tree was generated to map out the requirements of parts for the mailbox design to meet needs of the customer base. The team parsed these basic functions required by the customers for this product into 6 subfunctions. First is to protect components from weather. This includes withstanding inclement weather such as rain, snow, high winds, high and low temperatures. Second is safety. This includes illumination and visibility to prevent accidents due to poorly lit areas. It also includes preventing electric shocks from occurring in the presence of electrical connections. Third is assembly, which integrates the physical components into one working system. Fourth is customizability, which is one of the main differentiators of today's mailbox to a smart mailbox. This includes interchangeable batteries broken down to its types, displays, and power sources. Height adjustability is another customizable feature of consideration. Features are the subfunction that makes the function tree blossom with added automatic capabilities, such as weight mail, sorter, postage prints, pest control, and optical character recognition. Lastly, security system is an essential subsystem necessary to prevent theft, vandalism, and other unwanted tampering of a smart mailbox. Electrical access, mechanical access, monitoring, and alert systems are the types that were considered. All the main functions are necessary to design a system to receive and hold mail. We will now move into discussing our morph chart, which takes the function tree one step further to drive selection in our detailed design.
Hi, my name is Fawad Salim, and I'll be providing you with an overview of the morphological chart developed by Team 1 for our mailbox design. A morphological chart is a solution generation tool used to brainstorm methods of achieving various solutions to a given subfunction. Employing a morph chart without any limitations allows for original and creative thinking to identify the most appropriate solutions for each subfunction. The morphological chart is broken down into the following structure. Requirements are at the top of the tier, followed by higher level functions, subfunctions, and finally, possible solutions to those subfunctions. The requirements for our mailbox design were identified in the function tree presented by Victor. In order to identify solutions for these requirements, analogous requirements are grouped into higher level functions. The higher level functions for our mailbox design were classified with the following categories: interchangeable batteries, functional customizability, illumination and visibility, prevent electrical shock, protect components from weather, security system, assembly, and lastly, features. The higher level functions are then broken down into subfunctions. For example, the security system can be broken down into the following systems: electrical access, mechanical access, video monitoring, and noise alert. Finally, possible solutions are identified for achieving each subfunction. The solutions identified for the electrical access system are access using a fingerprint scanner, keypad which requires a PIN, key card access, and a Bluetooth connection which allows access through a mobile device. I will now turn it over to Jennifer to discuss the preliminary concepts.
Hello, I am Jennifer, and I will be talking to you today about our preliminary design concepts. The customer and technical requirements were reviewed by the team members, and an all-call for preliminary design concepts was released. All team members were given the opportunity to provide their concept, and in the end, 7 were submitted. Design Concept 1. This design contained an indicator light for mail being picked up and delivered, a scanner, and a sorter for junk mail. It also has a large compartment for packages so they can both be picked up and delivered to your mailbox, which removes the concern of security and the fear of the elements. Design Concept 2. This design was inspired by the top-rated priorities for the mailbox as determined by the customer survey. These were durability, security, and cost. Some of the features include a flexible solar panel to provide the power to devices and a scale for weighing packages. Design Concept 3. Some features of this design are the telescoping pole, which is used for easy height adjustability and storage, the customizable security features, junk mail sorter and shredder, and a customizable outer shell. Design Concept 4. The focus of this design is flexibility and modularity. This design allows the user the flexibility to insert, replace, or upgrade all of the electronic features of the mailbox. This design also complies with all USPS standards and suggestions. Design Concept 5. The focus of this design is customizability and premium features. There's a junk mail shredder, a digital scale, postage and label printer, as well as a fisheye camera. This design also adheres to all USPS standards and suggestions. Design Concept 6. This design utilizes the idea of modularity in design to appeal to a wide range of audiences as well as a wide range of prices. This design has a scanner which will confirm receipt of mail and sort the mail. The design also has a lot of optional features such as the mail shredder and additional security features. Design Concept 7. This design's features are a mobile application integration and real-time data processing, which provides all information about your mailbox and the contents in and around it. The intelligent user detection, which has a camera, a fingerprint sensor, and Bluetooth syncing capabilities. Next, Kevin will explain how we arrived at our final design concept.
Hi, my name is Kevin Johnson, and I'm going to discuss our team's method for selecting our final design concept. As was previously discussed, we had 7 different design concepts to choose from at the end of our in-team contest. Some of the features on these designs were expected, some were rather radical, and many seemed to overlap. In order to narrow down from this field of candidates, we polled the team again, distributing a short survey that asked them to analyze each design, picking out the features that they liked, picking out the features that they didn't like, and making suggestions for any changes. At the end of the survey, we then asked the team to rank each design from 1 to 7, 1 being what they thought was the strongest design, and 7 being what they thought was the weakest. To determine which design was best, we collected the survey results and tallied up the rankings of each design. The design with the most high-ranking votes would be the winner. Unfortunately, our results were not exactly clear-cut. We realized that we cannot completely narrow down the design field to one specific entry. Instead, we decided to choose the top 3 winners, and then formulate an entirely different design based on the key features of these 3 designs. From the survey results, we found that the top 3 designs were Design 5, Design 7, and Design 6, shown here. Each of these designs was rather unique, but many of their key features and design objectives overlapped. So, we decided to pick out the prominent features of each design candidate and create a requirements list, deciding which features we wanted to include and which we didn't want to. Of those that we chose to include, we categorized them as either a wish or a demand, and if we were a little unsure of a feature, we categorized it as indifferent. From this requirements list, our CAD team then stepped in and took control of the remainder of the final design formulation. The design concept sketches for our final design are shown here. These drawings would prove to be incredibly useful during the computer-aided design stage of our project.
Hi, I'm Javier Sanchez, and I'm going to present the final design concept. After evaluating the initial concepts, we determined the key requirements and objectives we wanted our final concept to meet and achieve. We found that the most requested features included the following: a compartmentalized mailbox which has the function of separating outgoing and incoming parcels, the capability of receiving and storing packages, limiting access of incoming parcels to authorized users, the implementation of technology for ease of use, notifications, security, and even self-sufficiency, and finally, giving users the freedom of customization by designing with modularity in mind. A view of the final concept is presented below. Let's now go into more detail to understand how each of these features are achieved in the final design. The overall shape of the mailbox maintains the common rectangular shape because packages and envelopes are also rectangular. There are 3 separate compartments: the outbox and package compartments, which are accessible from the front, and the inbox, which is accessible from the back. However, in order to allow for the mail carrier to deliver mail into the inbox from the front, a slot was created. Mail delivered into the slot slides into the inbox compartment. In the back, a small compartment exists to contain the smart components, which will be discussed later. A single large door is used to access the outbox and the packages compartments from the front, allowing the mail carrier to deliver packages and pick up outbound mail by opening one door. The contents of the inbox can be accessed through a hinge door in the back, keeping the user away from the street. The technology compartment is enclosed by a removable panel below the inbox door. Although a desired feature was the ability to secure all the compartments of the mailbox, we concluded that the logistics of granting mail carriers with special access would become too demanding. Thus, to compromise, we secured the inbox and technology compartments to only allow authorized access, while leaving the outbox and package compartments locked free. The inbox door and the removable panel are both secured using electromagnetic locks. These locks will be disabled for a brief period once a user has been granted authorized access. Environmental protection was another key demand. The two hinged doors in the access panel are lined with rubber seals, which protect interior compartments from water, dust, pests, and other unwanted environmental elements. The inbox slot was designed with a slant in order to deter rainwater from entering. Furthermore, a hinged flap was placed behind the slot. The slant in the slot guarantees the flap will remain closed, further reducing the possibility of unwanted environmental elements from entering the interior. To really bring this mailbox into the world of today and tomorrow, we have provided customers with the option to easily implement various technologies in order to augment the capabilities of their mailbox. LED panels are placed on both sides of the mailbox to serve both as displays of the house number as well as make the mailbox more visible at night. A smart panel was developed into which modules can be easily plugged, becoming immediately implemented without additional configuration procedures. These modules communicate with corresponding components, such as sensors, in order to increase the functionality of the mailbox. For example, a weight sensor can determine when outgoing mail is present, thereby moving the actuated flag to the vertical position. Modular components allow the customer to pick and choose which features he or she wants to have in their mailbox. The mailbox may be sold as a basic simple system which can then be upgraded with additional components. For example, customers could choose which form of wireless communication they would prefer, Wi-Fi, Bluetooth, NFC, etc. The modular approach to these components also grants the potential for small, cost-effective upgrades versus having to purchase a whole new mailbox. We believe this design is a competent concept going into the future. We created this design after gathering and evaluating the requirements of potential customers, then applying our engineering knowledge and design skills to create this concept. Shown here are additional renders of our conceptual design.
Hi, my name is LaShawn Mu, and I'll be discussing the future expansion of the Smart Mailbox. The design of the Smart Mailbox allows for interchangeable components to create a family of products. Currently, the base model allows for a solar panel, a weight scale, and various other smart component expansions. In the future, we can see the fruition of auto-labeling. This will ensure that packages and envelopes are accurately stamped and addressed. The Smart Mailbox does it all for you by synchronizing with your address book and printing labels directly onto your package. Mail sorting could also be in the realm of possibility, as OCR technology will enable the mailbox to separate important things in your inbox from the spam. The Smart Mailbox will not only serve to be just a mailbox, it will be equipped with security cameras to monitor your home and ensure the safety of your family. All these future expansions to the Smart Mailbox can be integrated with a mobile app. This mobile app will allow you to control all the functionalities and components within your Smart Mailbox.
Hi everyone, my name is Synthern and I will be doing the final wrap-up for our project. First, I would like to show you a promotional video by Autodesk which shows the future of design and engineering.
We are dedicated to helping you advance the way you imagine, design, and create. We already have one of the most broad and robust portfolio of solutions in the industry, but with the recent and explosive changes in mobility, touch-based devices, and access to computing power.
As you saw in the video, full-scale design can now be performed on tablets and even smartphones. These rapid advancements in technology are leading the way for using mass collaborative design platforms accessed by anyone, anywhere with an internet connection. Shown here are the learning objectives that were established by the team to take advantage of the new mass collaborative design environment. All of these objectives were successfully achieved by the team. The most important of these is assessing the feasibility of a recommendation for a design solution from potential customers. This was a challenge from an engineering standpoint that our team faced in incorporating many of the features desired by our customer base for the mailbox. Traditional systematic design methodologies, such as Paul and Bytes, are useful as a systems-level design approach to ensure successful design, but they still require slight modifications with the introduction of new tools and strategies such as mass collaboration and mass customization. This is our team's final design. This mailbox is fully customizable in terms of security hardware and integration with smartphones. Moving forward, this design can be upgraded based on new technology and changes in customer preferences. Thank you for your time in watching this presentation, and have a great day.